Alright, in this video we're going to be analyzing quadratic functions, and we're really going to be talking about them in reference to application problems and then how to look at them in Desmos. So first thing I want to talk about is looking at quadratic functions in a real life application problem. What do those key features mean when we're talking about a quadratic function? So some of the main key features that you have discussed previously with quadratics is you've talked about the y-intercept. So the y-intercept of a quadratic function in a real life application is the initial value. So we have that y-intercept, and that y-intercept is the initial value of some sort. So most of the time they're going to be talking about like the initial height of something, like an object being thrown off a cliff, or in something reference to an object being projectiled. So within that, we're going to be focusing on quadrant 1 because those are the positive values, and negative values in real life application are not going to make sense in this situation. So then the next thing that you would be looking at is the maximum, okay, or the minimum depending on the problem, and that maximum is your vertex. Okay, so that vertex, like in reference to, let's say that something being thrown in the air, it's going to eventually reach its maximum, and then it's going to be forced to come back down. So the vertex, we would normally think of it as x, y, but when we think about maximum, we're going to probably think about it in terms of time and height. So when we're looking here, we're going to make sure we're analyzing t stands for time, h stands for height. That is my x and y value. And then the next thing that we're going to be talking about is where it comes back and hits the ground. So where it comes back and hits the ground, if that's the application problem, that's going to be that x-intercept. That x-intercept is where that quadratic will eventually come to its end value. So they can call it a 0, they can call it the x-intercept. Like I said, most of the time the x-intercept represents the ground. They may have talked about maybe something worth the water, but where the level is 0. Now, a few key phrases that are super important, especially in application problems, when they're talking about that x-intercept, is they may use the phrase, how long was it in the air? How long in the air? If you're talking about how long it is in the air, then you're talking about that time that it was in the air and then when it came back down. So they're talking about when it came to hit the ground. They may also use the phrase hit the ground. Okay, so all of those are going to represent the x-intercept. So what we're going to do is we're actually going to look at this, and we're going to look at it in an application problem, and we're going to look at how to analyze it in Desmos. So looking at a couple of examples here, it says a ball is thrown into the air and has a height h of the ball after t seconds and is represented by this function. After how many seconds will the ball hit the ground? So this is that situation just a second ago where I was saying after how many seconds will the ball hit the ground? So if it's talking about hitting the ground, it's talking about that x-intercept. So in order to really see that x-intercept, we need to graph this, and we need to analyze this problem in the Desmos graphing calculator. Now, when you type this into Desmos, we're going to change this up so that we have x's and y's. So instead of using t's and h's, we're going to do x's and y's. So we're going to put that problem in. And when I'm doing that, just make sure you're very careful about what you're typing. Make sure there are no mistakes. And I can see a lot happening here. But what I want to do is I want to focus on my x-intercept. And that x-intercept is going to be in this focus area here is at 2, 0. But before we focus on that x-intercept, let's look at the general picture. So I'm going to focus on just on quadrant 1. But I really can't see that beginning value. I can't see the whole thing. So we're going to learn how to adjust our screen manually and make it fit nicely. So if you hit the little wrench, is the settings tool, you should see it says x-axis and y-axis. So right now we are fine with the x-axis. We can see where it comes back down on the x-axis. What we can't see is the initial value, the y-intercept. So we want to change how far the y-axis goes up. So right now it's at 16. This is going to kind of have to be a guess and check unless you are able to represent and understand that that C value is my y-intercept. So if you understand that that C value is my y-intercept, then I can go ahead and change that to, let's say, 50. I'm going to give myself a little wiggle room so I can see the graph nicely. And when I change it, I can now see where my ball was thrown up in the air and then it came back down. So I also want to see less of the x-axis. I see too much. Now you don't have to change this, but I just think it's nice to adjust it to have a really good graph. And I can see that now as it goes up and it comes back down. So a few things. So we have our y-intercept. Our y-intercept is at 40. It reaches a maximum of 42.4 feet. And it did that in 0.375 seconds. That's our maximum point. Because remember, x is seconds and y is height. And then it comes back down after 2 seconds. So it took 2 seconds for it to be thrown in the air and for it to come back down. So that x-intercept that we're looking for took 2 seconds. That is how long it took before it hit the ground. Okay? So adjusting the graph can be super important when you're trying to look at your key features. So then it says, when Brendan kicks a football, its height in feet can be modeled by this equation, where t is time in seconds after Brendan kicks the ball. What is the value of t? So that is going to be a key feature there, or a key important piece of information. The value of time when the ball reaches its maximum height. Okay, so I'm going to hit the home button here. The home button is on the side because we're going to start fresh and we're going to adjust it together again. So I'm going to do this in terms of x and y. So I have y equals negative 16x squared plus 85x. Now, I cannot see that maximum value. Okay, so I'm going to adjust this. So for my maximum value, this is where we're going to have to do some guessing and checking. Like I could keep scrolling, but eventually we'll see that it kind of goes between 110 and 115. However, what if it's something that's, in the thousands? You don't want to have to scroll that far. So you may just have to do some guessing and checking by changing your y-axis. So normally what I'll do is I'll start at 100 and just kind of see where it falls. And 100 wasn't quite enough, so I will change it again. Let's do 200. And 200 worked well. And then if you really notice that you're not making any significant change, then you might want to change it by some thousands. All right, so the problem is asking me for the maximum. So we have our y-intercept is at 0, 0. So when he kicked the football was on the ground. So it was at the ground level at 0. And it reached a maximum at 2.656 and 1112.891. Well, what does that mean? That means that it took approximately 2.65 seconds to reach a maximum height of 112.8 feet. And then, of course, it came back to the ground. It took approximately 15.3 seconds to come back to the ground. So it asked us, what was the value of t? We're looking for the value of t. Remember, the value of t is time when it reached the maximum height. So it's not asking me for the actual maximum height. It's asking me for the time it took to get there, which would round to 2.7. So a few key things. I'm going to go back. When we're looking at our key features, we're always going to be looking at three main key features. We're going to be looking at the y-intercept for the initial value, the maximum, which is going to tell us the time and the maximum height, and then the x-intercept on the positive side, because that's going to tell us how long it took before it came back down. We're going to focus on quadrant 1 because those are my positive values in the real world. And then, of course, when you're doing it in Desmos, you want to make sure you adjust your screen so that you are seeing exactly what you're looking for, whether it be the maximum, the x-intercept, whatever that may be. And you're going to adjust that x and y axis so that it fits nicely and it's easier for you to see.